Hello everyone. You're welcome back to MyDigital Tutors. If you're new here, thank you for stopping by. Uh, Here we do a lot of uh, solution to past question papers for all forms of exam, WAEC, NECO, JAMB, name it. So today we are going to look at uh, solving equation by iterative method. And the method we are going to look at today is a Newton-Raphson method. This is a powerful technique that is very easy and fastest way to find the root of an equation. That is to say, the value of x that will make f of x equal to 0. But don't worry, we are going to break it down step by step. The formula looks somehow hard, but it's very simple. So according to the Newton-Raphson method, it states that if x1 is the approximate value of a real root of the equation f of x equal to 0, then we can find a closer approximate root x2, which is given as x2 equal to x1 minus f of x1 divided by f prime of x1. So the equation actually looks like x n plus 1 equal to xn minus f of xn all by f prime of xn, where n here are a real number 1, 2, 3, and so on. So if that is to say, if n is equal to 1 here, so I'm going to have x2, that is 1 plus 1, equal to x is 1, n is 1, that is x1 minus f of x1 all over f prime of x1 and so on. So if n is 2, I'm going to have x3 equal to x2 minus f of x2 all over f prime of x2. So, so this is how you're going to iterate until you get to a certain condition. A certain condition is met, then you stop and conclude that the correct approximate value has been found. Are we together? So that is what we are going to be using to solve series of problems. So let us apply that formula to solve this question here. The question says, use Newton's method to determine the positive root of the quadratic equation f 5x squared plus 11x minus 17 equal to 0, correct to 3 significant figures, and we can also check using the quadratic formula. So in doing this, you have to follow steps. The first step 1, the step 1 is to understand the formula, right? You have to understand the formula. Then after you understand the formula, the next step, you define your f of x. So, which I've written the formula down for you, that the formula looks like x n plus 1 equal to xn minus f of xn. This is the formula all over f prime of xn. Is that correct? So here, after you have done that, the next step you need to look at is define your f of x and its derivative, which is the first derivative of what? F of x. So the next step, which is step 2 is define your f of x and its derivative is derivative. That is to say, f prime of f of x. So from this question here, our f of x is this. So our f of x is equal to 5x squared plus 11x minus 17. So this is f of x. So what will be our f prime of x? So we are going to find the derivative of this f of x. So f prime of x is equal to that is f prime is divide the x of what? Of these functions. So we're going to have 2 multiplied by 5, that will be 10x plus 11. So derivative of constant is 0. So f prime of f of x is 10x plus 11. Then, when you are done with that, the next thing to do, which is the next step, that is step 3. Step 3 now is to choose a good first guess. That is, you choose a good first guess. So that is the next step. Step. Your good first guess, we call it our x1, right? How do we get that? So we test a series of values. Like, let's assume that x is equal to 1. So what will be f of x from this our formula? So if x is equal to 1, so I have f of x equal to 5x squared plus 11x minus 17. So if x is equal to 1, I'm going to have f of 1 equal to 5 into 1 all squared plus 11 into 1, then minus 17. So if we evaluate this will give us 5 plus 11 minus 17, which will give us a 16. It will give us 16 minus 17. That will be equal to minus 1. So when you choose x equal to 1, we have that f of 1 is equal to minus 1. Right? So moving on. Now, what if you said x equal to 2? What will be f of x? So f of x, as usual, 5x squared plus 11x, right, minus 17. So when x is equal to 2, I'm going to have f of 2 equal to 5 into 2 all squared plus 11 into 2 minus 17. So simplify this. 2 squared give us 4. 4 times 5, that is 20. 20 plus 11 times 2, that will give us a 22 minus 17. When you do this, 2 plus this, 20 plus 22, that is 42, then minus 17, which will give us a 31. So we've gotten f of 2 to be 31. You can see from f of 1 is minus 1 to f of 2, which is positive 1. So there's a change in sign. So the moment we notice change in sign, then we can conclude that the value of x1, which is our first guess, lies between what? Between 1 and 2. Since that is where we have change of sign, lies between 1 and 2. So from here, we can just pick any of the range from 1 to 2 as our first guess. So here we can have 1.1, we can have 1.2, we can have 1.3, we can have 1.4, and so on. But you should ensure that the value you are going to choose should be closer to 1 than it is to the 2. So here I'm going to assume my first guess, x1 is equal to 1.2. This is my x1. So after getting my x1, the next thing is to come back to the function f of x equal to 5x squared plus 11x minus 17. So this is our function. So since I have gotten my first guess as 1.2, that is my first approximate value. Now, a better approximate value now is S2 is equal to, according to the Newton's Raphson method, the better approximate value than x1 is x2, which is equal to x1 minus f of x1 all over f prime of x1. So as simple as ABC, the next thing to do is our x2 will now be equal to x1. What is the value of x1? 1.2 minus f of x1. So meaning that in this function, I'm going to rewrite this function in terms of x1. So f x1 will be equal to 5x, right? 5x1 all squared, isn't it? Okay, plus 11x1 minus 17. So that will be f of 1.2 equal to 5 into 1.2 all squared plus 11 into 1.2 minus 17. So if we evaluate this, let us do it systematically. So here I have 1.2 times 5, 1.2 squared is equal to this. That is 1.44 times 5. That will give us 7.5, 7.2. So I have 7.2 plus 11 multiplied by 1.2 gives us 13.2 minus 17. So here I'm going to have 7.2 plus 13.2 minus 17. That is a 3.4. That is 3.4 as f of this. Now here, f prime of x. Remember our f prime of x. When you find the derivative of it, we have f prime of x is equal to, look at it here, the derivative of that is this one. So f prime of x is 10x plus 11. So we have f prime of x to be 10x plus 11. Is that correct? So meaning that we are looking for f prime of x1 this time around, which will be equal to 10x1 plus what? 11. Are we together? Okay. So knowing that f prime of x1, that is 1.2, will now be equal to 10 into 1.2 plus 11. And when you do that, that should give you 23. That should give us 23. So when you're done with this now, remember I stop here. So I now come back to a better approximate value x2, which is equal to x1 minus f of x1 all over f prime of x1. This will now be equal to x1 1.2 minus f of x1, we have gotten it to be 3.4 all over f prime of x1, which is 23. So we can have this one to be 1.2 minus, what is 3.4 divided by 23? That will give us a 0.1478. 1478. And when you do that, you're going to have 1.052. So 1.052. So if I want to leave my answer in three significant figure as said by the question, I'll leave it at, I'll say that my x2 is equal to 1.05. Now, so this is my x2. I can decide to go further to find a better approximate value, which is x3. And this time around, x3 will be equal to x2 minus f of x2 all over f prime of x2. Is that correct? So here, the same thing I have just done in the first one. F of x2 is equal to 5x2 squared minus 11x2 minus what? Minus 17. So sorry, it's plus. Yes. So then x2 is 1.05 as an approximate value I'm using. Okay. This will be equal to 5 into 1. Okay, let me use the correct value here, which is 2. So 1.052 1.052 all squared plus 11 into 1.052 then minus 17. When you do that, this will be equal to, when you do that, you have here to be 55 or 5.5335 plus 11.572 then minus 17. So the final answer here should be 0.1055. That is my f of x2, which is this part here. So also f prime of x2 will be equal to 10x2 plus 11. Is that correct? So f prime of x2 1.052 is equal to 10 into bracket 1.052 plus 11. So when you do that, you are going to have 21.52. So we have 21.52. Then you can now go back to the formula x3 equal to x2 minus f of x2 all over f prime of x2. So what's my x2 now? x2 is 1.052 minus f of x2, which I've gotten here, that is 0.1055, all divided by f prime of x2, which is 21.52. And when you do that, you're going to have it to be 1.052 minus 0.00049. So press your calculator. Your final answer should be 1.047. And if you approximate to three significant figure, you have 1.05. 1.05. So as you can see that here my x2, here my x2 is equal to 1.05 and my x3 is equal to 1.05. As in, if you take to the degree of accuracy, which is a three significant figure, you have the same value. While your x1, the first guess was 1.2. So by the time you have x2 and x3 very, very close to each other or equal, then you stop. Are we together? So you stop, and therefore the correct approximate positive, according to the question, the positive root of the quadratic equation is equal to 1.05. You can now test this to see if it is true using a quadratic formula. Now, if you have this question that f of x squared plus 11x minus 17 equal to 0. Using quadratic formula, you have your a to be equal to 5, you have your b to be equal to 11, and you have your c to be equal to minus 17. So you can have x1, 2 is equal to minus negative b plus or minus root of b squared minus 4ac all over 2a. Now, when you do this, you're going to end up having this to be minus 11 plus or minus root of 11 squared minus 4 times a, which is 5, times c, which is minus 17, all divided by 2 times a, which is 5. Are we correct? So this will be equal to minus 11 plus or minus root of 121. Is that correct? Minus times minus, that will be plus. Then we add everything together. That is 4 times 5 times 17. That will give us 340 rather. Everything divided by 10. So this will have minus 11 plus or minus root of uh, plus 340. So we're going to have root of 461 all over 10. This will be minus 11 plus or minus, what is root of 461? That will give us 21.47. 21.47.471, let's leave it like this, all over 10. So this implies that one of the roots could be equal to minus 11 plus 21.471 all over 10. And the second root could be equal to minus 11 minus 21.471 all over 10. So let's see what we have here. This is minus 11 plus 21.471. That will give us divided by 10. That will give us 1.0471. And let's see what we have here. This is minus 11 minus 21.471. This divided by 10, which is minus 3.2471. Remember, the question said the positive value, right? So the positive value we have here is x1, which is the same thing. By the time we approximate to 3 significant figure, we have 1.05. I hope you can get it. So this is how to use a Newton-Raphson method to iterate equation and solve it perfectly. Thank you for your time. See you in the next class where we are going to apply this formula or method to solve a more complex problem. Thank you. See you in the next class.